You may have noticed that when I'm talking about defects in 3D printing, I use the word stringing a lot. Now, stringing is a really common defect that you'll find when you're trying to print in between two columns, and as your nozzle is traveling or moving without printing, it's leaving this really thin, almost spider web of plastic in between the two nozzles. Now, it's not the worst thing in the world to get these. It's a really common defect. You can fix it just by getting a lighter and kind of wicking under it, and then all the bits of plastic curl away from it. Easy fix, but there is a way to calibrate your printer and calibrate your Cura settings so that you can eliminate it altogether and you don't need to do any post-processing whatsoever. The benefit of this is that it's less time of your spending on post-processing, and you're putting the material that should be going into your print back into it, so you don't end up with any under extrusion. Now, we talked about retraction briefly in our Cura videos, where we said, well, how much are you pulling back and at one speed? And I said, oh yeah, I do 4 millimeters at 35 millimeters per second. But where did I get those numbers? Where did I pull them from? Well, if you go on the internet and say, hey, what are your values? People will throw up 6 millimeters at 25 millimeters per second, 2 millimeters at 50 millimeters per second. And there seems to be no cohesiveness between it. Everyone has got a different value. So within this class, we're going to be printing a whole series of retraction tests so we can nail those values as good as possible. And as you do it, you'll be noticing all the defects. You'll notice that some just string a ton all the way. And how does that affect the stringing all the way across between different dimensions, between different speeds, between different retraction distances, and what does that all mean? So first off, we can actually talk about the complete opposite. So what happens if you have retraction turned off? Well, you'll notice that your prints look like hot garbage. There is absolutely way more than stringing. It is now an annihilation of your print. If you have your preheated nozzle just kind of running, you'll notice that plastic just oozes out naturally. And imagine that happening all the time while you're printing as well. Your print will have lots of curls, lots of hair, lots of nerds and scars all over it. And the simple fix is just checking this little box in your retraction settings. So when talking about those retraction values, we're really only worried about two things. How far is our extruder nozzle pulling our material back, and how fast is it going? You'll notice if you look at the extremes, going at 5 millimeters per second and 50 millimeters per second, they look bad, but in different ways. And we'll kind of go into it a little bit now, what that actually means. So for this print, it actually changes as it goes level by level. It goes from 1 millimeter of retraction at the bottom all the way up to 6 millimeters at the top. And by printing a series of these, starting at 5 millimeters per second of the speed of it pulling back, and then going in 5 millimeter increments all the way up to 50 millimeters per second pulling, you'll notice, again, right about in the middle, there is a sweet point. If you look at the very, very bottom, you'll notice that it really is all stringing. And as you go through the next level, it's a little bit better, and then a little bit better, and a little bit better. This is because if you only pull back a little bit while you're traveling, it's like you didn't do anything at all. But if you retract way too much, if you go all the way up to 6 millimeters at the top, well then your material is just going to flow naturally regardless of how much you pull it back, and you can actually end up causing a clog in your PTFE tube because you are now pulling molten plastic way too far up and then pushing it back. And that smear of plastic can then cool and then build up layer after layer after layer, and then all of a sudden you have a clog and your print is ruined. So there is going to be some place in the middle where you'll notice it looks perfect. And for us, I found that I have the best settings at 35 millimeters per second at 4 millimeters. This seems to be my sweet spot, but it will change based on your printer, your filament, your environment, everything like that. So we are going to be going into Cura and showing you exactly how to make this type of model. So to make these retraction towers, we're going to do it in a slightly different way to how we did the temperature tower, where instead of downloading a model and then having to go through every single layer and slice it ourselves, we can actually work with the pre-built models that's already in Cura. So to do this, we're going to go up to the right-hand corner where it says Marketplace, and we're going to download what's known as a plugin. Now, the plugins are basically just bits of code that other contributors have put into the software, and they allowed us to basically download and manipulate Cura in certain ways that we want to. And we're going to be downloading one called Calibration Shapes. This one down here is Calibration Shapes, right there. Let's go ahead and install it. And before we actually get going, let's go agree. We actually need to restart Cura. So let's go ahead and say quit Cura, and then we'll open it back up, and then we can go ahead and find these files that are already pre-made into Cura now. So now that we're back in Cura, if we go up to extensions, you can see parts for calibration is right there. And there's a bunch of really handy ones that I use all the time. Things like calibration cubes, retraction towers, all the goodies in here, but we're going to add a retraction tower. Now this is a pre-built one, and it goes from 1 millimeter of retraction up to 5 millimeters in retraction. Usually for my models, I want to push it up to 6 millimeters, so we have a little bit extra manipulation, but working with this model will be perfectly fine for us. And we're also going to be going up to extensions, post-processing, and then modify G-code, and we can add a new script just like we did with the temperature tower. So just like the temperature tower, we do want to make sure all of our layers are at 0.2 millimeters. This will just have it print a little bit faster. But because we're working with retraction, we also want to go down to travel and mess around with this a little bit. So for this very first print that we're doing, we're going to start at 1 millimeter of retraction at 5 millimeters per second, and then we're going to be progressing all the way to 50 millimeters per second. So we have to make a fair few files, but the only thing that we're going to be changing today is the retraction speed and the retraction distance. So let's go ahead and change this to 1 millimeter at 5 millimeters per second. And you can go ahead and click slice. And this will, or if you don't change anything right now, this will give you a really, really terrible print because it's really not retracting all that much. And well, you're just going to end up with a lot of strings. So now we want to go up to extensions, post-processing, and modify G-code. And the script that we're going to put in is actually retract tower, which comes from that plugin that we just added in. So by putting in all of our values in this, we can make one file for our 5 millimeters per second. So let's start off. So our command, we don't want to change the speed, we want to change the distance. Our starting value is going to be 1 millimeter or 1 millimeter of retraction. Then our increment is going to be up to 1 millimeter of increment. So it's going to start at 1, then it's going to go 2, 3, 4, 5 millimeters of retraction. Our layer change is going to be every 38 millimeters. Because this model is from the same people that made this plugin, these numbers should be perfectly normal. The layer offset is the height of the base right at the very, very bottom. And yeah, we can have all the details displayed at the bottom. If you want to download a completely different retraction tower from Thingiverse or the one that we made, then you'll just have to slice it and then see what layers all of this adjusts. But this is all looking pretty good. So now when we close it and we can go slice, then we should have a perfectly good model for our 5 millimeters per second retraction test. So you can go ahead and click save to disk to save this 5 millimeters per second retraction test. And then we need to do a few more. So we don't just want to print one, we need to check all of our retraction speeds. So I want you guys to go down, and instead of 5, we want to bump this up to 10 millimeters. And our script is already locked in. It's already saved into this folder. So you can hit slice and then save this one as the 10 millimeters per second. So we want you to do this from 5 millimeters up to 50 at 5 millimeter increments. So you should have a fair few folders to go through, but as you can see, each one only takes about 45 minutes, so it shouldn't take all that long to get through all of them. And just like the temperature tower, as soon as you are done with all of these files, go back down to this script and delete your plugin. And anytime you are done printing, make sure you flip it over and write in Sharpie what that distance was, and then you can lay them up and see exactly which setting you find the best results. So now that you're done printing all of your files, you do want to make sure that you write with Sharpie on the underside exactly what measurement it is. And make sure you do all of these retraction tests after you dial in the temperature of your filament and your extrusion multiplier. That'd be your E steps for your extrusion motor.